Hi there. What is the bias variance trade-off in machine learning? So machine learning is about capturing the structure present in the data. Mathematically, this means learning functions that have enough representation power to capture the structure in the data. Now, on the basis of representation power, models can be of two types: high variance and high bias. High variance models have high representation power. High bias models have low representation power. So one would think, why would we even need low representation power if we can get high representation power all the times? Well, the problem is there is a risk of overfitting to noisy and unrepresentative data in case of high variance models. Why? Because they tend to approximate noise as structure in the data. For example, in this case, you see this sinusoidal structure with some amount of noise here and here, but because this is a high variance model, it approximates the noise as the function itself. On the other hand, in the high bias models, even though this model has some sort of periodic nature, because the model has a lower order, it sort of approximates to a more linear quadratic type of polynomial. Now, in many cases like dimensionality reduction and feature selection, which are important things in machine learning, we want to go from a high variance model to a high bias model, and we do it using regularization, which is essentially reducing bias by reducing variance by introducing bias. Some of the common techniques are ordinary least squares, sparsity constraint, etc. In all these cases, what we are doing is we're trying to add additional constraints to the very highly varying high variance model, and we are trying to narrow it down to a high bias model by reducing the number of important features that are present in the dataset. From an implementation perspective, a generic neural network is a very high variance model. It can very easily fit noise and represent it as structure in the data, whereas it's completely noise. On the other hand, iterative algorithms can be very simplistic for capturing complicated structures. So ideally, we would want our model to lie somewhere in the middle of these two extreme ends, wherein we have enough variance in order to capture the complicated structure in the data, but not high enough that it approximates noise also as structure in the data. So hopefully this explanation was helpful. Thank you.